structural engineering and solar. Who would have thought, right?
Yeah, wild. I did not have this listed as a possibility ever.
Me neither.
Did you have to upskill to transition, or did you think that a lot of what you learned before was pretty much applicable?
I remember getting off that call, just sitting there like, oh my God, did I make
what have I
done? What have I done?
Greetings and welcome to another edition of the Sounds of Solar podcast. Your host today, I'm Christoph Brun. Joined with me, as always, is this fine gentleman over here.
Praddy.
Russell.
Russie.
For
the people in the know.
That's a reserved nickname.
That's
for
in Vegas only.
Very few people. Not one.
Well, on today's show, we have a very special guest, Abby Reetz, Structural Department Manager at EVS. We're going to talk about her history in structural engineering, where she was, where she's going to be, and where she is now. And Abby, welcome to the Sounds of Solar podcast.
Thanks. Excited to be here, hanging out with you guys again.
Yeah.
Welcome.
Yeah, absolutely. So, structural engineering and solar. Who would have thought, right?
Yeah, wild. I did not have this listed, as a possibility ever.
Me neither. As a structural engineer, I figured, why would you need to engineer that piece of steel that just sticks up out of the ground? Like, that seems very simple. But as we know, it's not.
Right. And even if it was, I don't think I would have ever really been interested. I would have thought it'd be clamps for things,
right.
Small things, and not something on this large scale that's complex and exciting. So just super fun.
Yeah. Before we get too far into that, so you've been in structural engineering for 10 years, roughly?
Not quite. A little shy of that. Yeah. But, since 2015.
So where did it all start?
I started at another local company in central Minnesota doing industrial and agricultural structural design work. Mm-hmm. So slit form feed mills, silos, warehouses. Yeah.
A
slit form. So when you pour concrete, you got forms, mm-hmm. but they put it on hydraulic jacks, and as they pour the concrete and it cures, it, the form slides up.
Oh, that's cool.
Yeah, it's really cool and also terrifying when you're on the top of it, at the end, then going down the scaffolding stairs. It was a frightening.
So you were out there.
You're out there. Yeah.
Where was this at? You said somewhere in the middle of Minnesota?
Plymouth, actually.
Oh, Plymouth.
Yeah,
Plymouth.
Yeah. Little company
Where did you go to school?
South Dakota School of Mines and Technology, but I think they changed their name recently.
Oh.
Just South Dakota.
And that's in Rapid City?
Rapid City, yeah, with the Black Hills.
That's a cool spot
to live.
That's
the cool spot, yeah. That's the good corner.
That is the good spot of South Dakota. No offense to anyone lives there, but man, the eastern part is just like the eastern part of North Dakota. There's nothing there.
It's a vibe. So when you were in Rapid City, what were the things you liked to do?
Yeah, my older brother was actually doing environmental engineering out there, so I'd go fly
Is that how you?
Yeah.
I should go check this place out.
Yeah, exactly. So it's all engineering and science students. Yeah. So there's no English.
Really?
There. It's a bunch of nerds in one place.
Really?
Yeah, it was a weird university.
So this is like Michigan Tech too, I bet, right? Isn't Michigan Tech kind of the same thing? I don't know.
I don't know, honestly. Yeah. But yeah, so it was kind of a weird place. The women to men ratio when I started was 1 to 10. Very few women.
To 10 men.
Yeah. So, and it was better by the time I graduated, which was
1.5 to 10.
I think they had a pre-med program by that time, so it was 4 to 10 or something like that.
Okay.
Yeah, not bad.
Cool.
But
so then you came back to Minnesota, working in a typical consulting firm, structural engineering buildings, and you did mostly ag type buildings though, right?
And I'm going to say it's a lot more fun than typical buildings because you're supporting these heavy pieces of equipment within these concrete buildings. So, really heavy loads and heavy designs and weird connections. We did a lot of retrofitting. I worked on a feed mill that was built in 1930, and we had to put all this new equipment in, and I don't know. It was a lot of fun. A lot of creative engineering, which you don't get traditionally. So
what's traditional when you say traditionally?
I don't know, building a target.
Okay.
Yeah.
Precast walls, joists. Some people love it. Not for me. Little just too.
That was my background, was typical. But I worked specifically in precast, which was delegated specialty design in buildings. So the things we did were, we did a lot of the mixed use apartment buildings that you see built everywhere, and which I think are great, honestly, because they're more of a honestly more of a European approach to housing, and retail on the first level, housing on top, and then we have the precast opened up a lot of possibilities with the underground parking. But yeah, that's what and that's very typical stuff, and I enjoyed it for what it was at the time. But then solar came along. How did that happen? I mean, you went for, because we're programmed to think as structural engineers, like, I got my degree in structural engineering, I'm a structural engineer now. And it's like, when you make that change to go into solar, it's a step into the unknown. So how did that all shake out?
Yeah, I mean, this was the end of 2020, so I was already working remotely from my previous job. It was just kind of getting maybe the right time for me to make a switch. Needed to do something new, kind of grow outside of, my first job out of college, right? You kind of get put into a box of who you are, and it's nice to start something new, redefine yourself, learn new things. So I started looking for new jobs, and this popped up, I think, on Indeed or something like that. And I was just right away, I was like, this is cool. Yeah. Never thought I could be a structural engineer or do structural engineering for a solar firm. So right away I applied, and I kind of, put all my eggs in that basket, really hoping to get this job. And, we got the interview set up. They went well, and it's just like the rest is history, man. Like, so yeah, it was weird finding a new job though, COVID, right?
Yeah.
Going from remote, starting a new job remote, but, honestly, EVS did it so great, like no complaints.
Did you have to upskill to transition, or did you think that a lot of what you learned before was pretty much applicable?
Yeah, it's all about like knowing how to learn and knowing how to apply those real basic fundamental skills to anything that comes your way. So that previous job I had really set me up for that, because it was a lot of weird problems and, that we had come our way. So yeah, I feel like I was really prepared to learn something new. And, I know my first day, like we've got this tool where we design piles. And it's very specialized. A lot of programming goes into it.
It's a ridiculous feat of engineering. It's insane.
Yeah, I remember Miguel showed it to me, and he did a real high-level overview. And this was like, I was the fourth person on the department, like very new. Yeah. A lot of pressure to like go fast, and we were just busy. It felt like a little startup, right? And so Miguel just showed me this spreadsheet, 30 minutes, real high level. And I remember getting off that call, just sitting there like, oh my God, did I make
what have I
done? What have I done? And, the first day was a little rough, and, it just is what it is. Second day, honestly, from second day on, I was all in. I was ready to go. Yeah. So, just a little bit of a hurdle to jump through that one, but it was obviously no fault of anybody's.
Now we're kind of in the present. So what is it that we do in structural engineering at EVS in utility scale solar?
Yeah, what we do is we design PV foundations for utility scale solar. We also do miscellaneous foundations, but primarily like our bread and butter are those PV piles for solar racking manufacture systems. So like a Nextracker or ATI, Game Change, there's a handful of them out there. And it sounds so simple, right? Like a single wide flange pile driven into the ground. But it's the scale of these projects that make them so complex and challenging. You're doing thousands of acres of these off of a single geotechnical report, and, trying to optimize it so that they're saving money by having, enough pile types, but not having so many that it's impossible for those guys to install, things like that. Yeah, I mean, at a high level, that's what we do.
Just listening to what you're saying about the different pile design, trying to optimize it. Are you only using one geotech input data to do the design across the site? Do you have like a singular?
It's not quite that simple. We have a single geotech report, and so that engineer will go out, they'll do the pile load testing, and then...
Do they do that at different locations on the site?
They do.
Okay.
Yeah, they'll do it all across the site and kind of get like this collective data and then sift through it and kind of find trends. And we typically have a handful of zones. Sometimes it is one, right? Some of these projects in the desert, like it's sand. Just sand everywhere. That's great. We love those. They're very simple and just like easy to optimize. Other projects, like you'll see it more, I think, in like the Midwest, where you're going to have all these different zones and, they're going to be different. You might have 3 zones for axial properties. So like how stiff the soil is vertically. And then you're going to have another 3 zones for lateral, so horizontal soil properties. And they don't line up with each other. So you're at 6 zones. So then we go through, we look at our designs, and we start finding trends, because we're not going to do 6 different designs for these unless the client wants that.
Sure.
And then we start lumping them together and try to parse it down to maybe 3, maybe 2, whatever makes sense.
To give us a scale, how many piles are we talking? Like 100 megawatt? Just
No,
to
you should
understand.
guess first. No, you got to guess
yeah.
first.
Oh. Fun.
Hoy, 100,000?
Okay.
Well, let's say, yeah.
For a 100 megawatt project?
100,
Hold on.
let's,
100 megawatt, let me guess myself.
Yeah, 100 megawatt.
You said 100,000?
Yeah.
It's like 185,000.
I think you guys are actually both high for
Oh, really?
I think 100,000 is maybe like a 250 megawatt.
Okay.
Okay.
But I'm speculating here.
I'm trying to think.
You've done some bill of materials recently, I feel, maybe.
Yeah, I've done a handful. So I'm trying to think like what size those projects were. I think recently we had one that was like 100 or 125 megawatt project, and we were at like 59,000 piles.
So is there, this is my limited knowledge on anything structural for solar, but is there not a different pile design if you are an outside array and in like the beginning and an interior?
Yeah, there's all of these different considerations. When I consider, like, we look at reveals, right? And then that's going to include that exterior, interior, edge. That reveal and that geotech zone, that's one lump of designs. And so then we kind of break it out by different reveals and geotechs. And those are going to have 6 to 8 different pile types usually.
When you say reveal, can you, for us non-structurals, can you explain what reveal means?
Yeah, that is just how high the pile sticks up above the ground.
Stick up height is the more layman's term, I would say. Yeah.
No, what's the reasoning behind, because I have an idea, but I don't know because I never really asked a question. The exterior piles, why are those typically a bigger pile? What's the thought on, I don't know what the thought is. It wind?
Yeah, it is wind.
Oh,
It's,
okay.
those trackers are taking the brunt force of the wind, right? While they're shielding some of those other modules behind them. So that's why we're seeing a couple rows of those exterior heavier piles. They're taking most of it, and then the interior ones will be a little bit smaller.
And then all the dry piles obviously are bigger ones too. Typically.
Yes, all the ones with the motors, that's the real heavy pile that takes most of the load.
Well, and that segues into maybe an even deeper topic that we're facing a lot right now, talking about the motor piles. And so I think it's easy to think, on the outside, okay, yep, the tracker is going to be tilted, the wind's going to hit it, so that's the design case, right? That's not true, right? Because we have weak axis. Can you talk a little bit about how weak axis, what that means, the other direction, loading the other direction, and how we are dealing with that these days and the issues we're seeing?
Yeah, so I guess first I'll kind of explain what weak axis and strong axis are.
Would you say
I don't
that is?
Is it the weak y-axis? No.
Yeah.
No.
Yeah, you're on the right track. So you have these wide flanges,
I-beams. I-beams.
I call them wide flanges. That's that's the shape.
Proper term.
Yes, I can say all these other acronyms, but we won't go into that today. So you have your wide flange, and if you're looking at your eye as if it's written up and down, that's your strong axis, right? That is going to be, you can put the most load on that pile. If you try to push it side to side, it's going to be stronger there. If you try to push it horizontally, looking at paper, that's weaker, right? It's a lot more narrow, not as much steel to resist those loads. So these piles, the way they're installed is if you're looking north to south and that's the direction your tracker is running, the strong axis of the piles are going in the east to west because that's where all of the wind is getting caught by the panels and being pulled to the side, right? You have wind directions and everything like that. And the racking manufacturers, they do all these wind tunnel testing and get all this data, and they apply it in 2 directions for us. So strong axis, and then you're looking at weak axis along that north and south direction. And these sites aren't flat, right? You've got slopes. So like a roller coaster, if you think about it, you've got your plane sloped down, that gravity force is going to pull it down the hill. So now we're designing these piles in the weak axis for these loads, which we're going to have to upsize the piles for, and so we're constantly reevaluating our designs as, these racking manufacturers are updating their design criterias, right? Like as we get better, they're getting better. They're looking at the data, how they can improve, how we can improve our designs together. So that's kind of one of the things, we've been discussing internally a lot lately, is just due to some recent changes made by them that we're maybe applying a little bit more load than we were before.
So, and explain to me in like the process of 306090 IFC, at what point is your design pretty locked in and they're buying material based off of your design?
I mean, our 30% designs, if we're looking at just the pile sizes, are usually pretty accurate. It all depends on the information you have, right? At that stage. Sometimes we have final geotech reports. Those values, those designs aren't going to change. 60% is usually where our pile designs are pretty finalized, because we do have all of that information from the geotech, the corrosion, the wind loads. What makes it hard to order piles is the changes you guys make.
Russ?
Any changes?
No, it's actually prodding.
You're right. You're studying. Yeah, I should be looking at prod.
He's like, oh, that line.
It's just
like the line where you're like, it's not just a line, Proddy.
it's just easier to throw Russ under the bus.
It is.
Oh, Rusty.
It happens.
Yeah, so it's more of like the changes that are happening in the site layout. Also, a really big one for us is hydrology. So Civil is constantly updating their design, updating their grading, which is changing the hydrology model. And then we take that hydrology model and we look at it, we overlap it with our site plan with the piles. And then we look at like, how tall do these piles need to be to keep the modules out of the water in case there's a flood event, right? So it changes the quantities. We know what sizes these piles are going to be generally, but we need to like have that final information to tell the clients, like, you need to order X thousand number of these piles versus, like the 30%. We're just guessing.
And not all clients are the same too. Some of them own that. They take ownership of, bill of materials, etc. And we can do that too, of course. One thing I wanted to come back on when we were talking about weak axis stuff is seismic. How do earthquakes impact our designs?
Yeah, seismic is a big one because unlike wind, where you're getting most of that load in the strong axis, seismic goes everywhere. It's going in all directions. It's all based off of the self-weight of the system and the seismic loads in those areas. So now we're designing these piles in the weak axis for, I don't know, what's the highest one we've seen lately? Like 2,000 pounds?
Yeah.
You've got the big ones.
Yeah. So, it seems like everyone wants to build projects in the New Madrid fault zone, which is, it's near Missouri, Arkansas, like Memphis, Tennessee. If you think about that kind of area, a little bit north of there, that's the New Madrid fault zone. You can look it up. There was a very famous couple of earthquakes that happened there in the 1800s, which were significant. And the way that the tracker manufacturer delegates how those forces go in, they go into the motor pile first, and then you can add seismic piers after that. And when you're dealing with very high seismic loads, suddenly it's like that's a lot of weight, because it's the weight of the system that responds to the shaking of the earth. So you have this giant weight and you're trying to put it into a couple dinky piles into the ground, and it suddenly turns into a big engineering problem. And that's coupled with the other design considerations you have to consider. So it's like big brain stuff.
So do you give some gap so that the piles can move or something? Or
no? Maybe we should get a slip in there, so get some bearings in there so they can just go whoa.
Yeah, that's a great idea. We're going to put it all on a slinky based system, I think, moving forward.
That's what they do with the buildings, right? They have like that
mast. Oh, maybe we should get a tuned mast damper on there. Oh, yeah,
that'd be cool.
For the earthquake, that's not going to happen.
Yeah.
So,
But one question I had about that strong axis, you said you feel like there's more weight now. Is that because the module manufacturers are changing, making some updates? Maybe they're moving to higher wattage modules. Is that one of the reasons as well? Or
I mean, panels are getting a little bit bigger. They are getting a little bit heavier, but that's a very, very small part of it.
Okay.
The main reason for this change is how racking manufacturers are designing their system. Not saying it's wrong. They're just relooking at how these loads are transferring along this 280 foot long tracker that's all connected by a hollow steel tube, and how those reactions are going to look during a seismic event. these motor piles are the stiffest, right? So most of that load is going to go into the stiffest pile. So then the loads increase. And so we do some analysis in-house too, looking at the stiffness of all of the piles and kind of transferring it. But it's really set how they, describe how the system should be designed, right? Because we've got to kind of work with what they provide us, because it's a full system together. They're putting their equipment on our foundations.
And they are reliant on the module manufacturers to figure out their system as well, right? So I guess it's
a lot of parties.
It's a lot of parties, okay. Interesting.
Is there any auditing that goes on from like previous designs to see if and there must be, if that's why they're changing their requirements, right? Like, were projects before maybe the piles weren't sufficient enough, or there wasn't enough fluff in there? I'm just wondering, like, or what's, have you seen anything like that? Like, I know the reason I'm asking is, like, in electrical, sometimes they'll be like, you completely over-engineered this. We looked and we saw, or that was under-engineered, so going forward, we kind of do like this.
I don't think it's due to that. We haven't had any issues with the piles. They're incredibly rigid, and they're very durable. Yeah.
Okay.
Like these are the last thing to fail.
Yeah.
The modules are probably going to fly off, or like there's a lot of other things that are going to go wrong before these foundations actually start having issues. And they're heavily designed so that like we don't have issues with them. But, the reasoning for it is, I think, is that, as this industry matures, we're all starting to really refine the data and the, like you see this too, probably from a lot of like inverter and BESS manufacturers, like their manuals are getting much more detailed and much more professional and whole. And we're just seeing that on the racking side too. We're just getting more detailed into how they would like to see the foundations designed so that their system isn't going to be negatively affected during a seismic or wind event.
So a question there. I actually have a site that got hit by a tornado, and you guys are building for that type of an event, or no?
No, nobody designs anything for tornadoes unless they're hospitals, right? Like,
okay, well, I don't.
It's a great question. It's a great question. So, like, we can get into this. So for structural design, we have risk categories, right? A risk category 1 being like, I don't know, a farm, like a shed out in the middle of nowhere. A lot of these solar sites are designed for risk category 1 because there's no negative or direct impact for like endangerment to human life.
It's a non-occupied structure. It's in relative terms, it's like a barn or something, like a storage shed, which is, even not to open another can of worms, is really even more over designed than it needs to be. Also, because the code, the mechanics of the code, they're for buildings. These are buildings. I
remember you talking about this. Are they not? I thought you said they were redefining that code, weren't they?
Yeah, and it's going the opposite way.
Really?
That's the problem. Yeah, it's going to be, I think IBC 2024 specifies that it's, all ground mount utility scale, like PV generating or electricity generating installations need to be risk category 2.
Why? Oh, wow. What's the reasoning? Because
they're power generating facilities, but the problem is that it's not like, that's not the right way to think about it, at least in my opinion, because the design lives are short. They're finite. They're on leased land. So 25-year design life, that like the project is done. You're going to build a new project before you're going to, maintain that. Whereas that's the big difference with buildings. It's like, how many warehouses that were built in 1900 are now breweries? Like, they're still in service, and that's because buildings are very rigid. They are over designed. And then think about, now we've applied that to piles that are definitely going to get pulled out of the ground in 25 years.
So you're saying, like, your opinion, you don't agree with that. Is there a way to get on that board to have an influence? I know, there's some IEEE standards where I have differing opinions, and I'm on a couple of the boards trying to like change the narrative. Is it something that we're looking at?
A former colleague of ours is definitely doing that actively, but all this stuff was put in motion a couple of years ago. So it's kind of before, we had other people questioning like the implications of this, because, so risk category 1 to risk category 2, there's a jump in wind speed. Wind speed is an exponential factor in determining the wind load. So as you jump up 5 miles an hour, like, sounds kind of trivial, but it actually is like that, like an exponential curve.
Yeah.
So, folks that are buying the steel, they don't like that because we've built all these projects at risk category 1 and they're fine because the piles are already over-engineered.
Yeah.
So now we're going to just engineer them even more. So there's options, I think, moving forward to right-size the risk, but it takes a lot of buy-off from stakeholders. So, anyway.
Wow, that was a kind of that was a good.
Now I'm fired up.
Yeah, you got them all worked up, man. That was the wrong question to ask.
No, that's the right.
No, yeah. It's very interesting.
Yeah. Wow.
No, but your argument makes sense because it's not firm capacity, right? Renewables is not firm capacity unless you put a battery on it or something that makes it firm capacity, right? So it is intermittent, basically.
Yeah.
So it doesn't really make sense to design it to a risk category 2.
Okay, the discussion of risk and related to PV and then coupled BESS.
Yeah.
So conceivably, a storm event happens, it knocks out the PV, you don't have any generation, but you have BESS that can still deliver power. Should that be a higher design criteria, shouldn't it? Well, how does the grid actually work? I mean, if your PV, because I think that's the misconception, right? Is that you could make the argument that there's a PV solar facility here and then there's a hospital here. Shouldn't that just always be powering that?
But that's a different application, though,
right?
Like, so that's a sort of like a microgrid where it's PV dedicated for a facility, right? But just generally utility scale power is just feeding into the grid.
Exactly.
Right? So at that point, it's not firm capacity because renewables is intermittent. Like, it's only when the sun shines. If the wind doesn't blow, your wind turbines aren't generating. So really, you can't count that as capacity unless there is a battery connected to it that can say, when it is intermittent, the battery can kind of pump into the grid and kind of back it up, sort of a backup essentially. So unless you have that, you can't really call like a solar facility like as a firm capacity, or you can't count that as firm capacity.
Yeah.
So I think that's where like the application you're talking about is a microgrid, which is kind of different, but yeah.
Right, and places like hospitals, I mean, by default have backup generators. And this is where, like, I think there's a misconception about, like, as we transition our energy sources, yes, we can have all of these intermittent intermittent sources versus firm sources. Things like natural gas have a place for a long time because the advantage of natural gas is it's instantaneous, on-demand power. So you can there's a huge storm event, you see a dip in power transmission, fire on the natural gas plant. Like, this is going to be a thing for a long time because we don't have, I think that's our option, right?
Yeah.
As we build more renewables, the demand might be less, but like I don't know. I think there is a misconception that said like, oh, well, what if the hospital needs power? What if all the PV's not working? It's like, that's just a fundamental misunderstanding of how energy works.
Yes, exactly. Yeah.
I think at the end of the day, that argument that you brought up about it being a risk category 1, it kind of makes sense, especially thinking about it from the firm capacity standpoint.
Yeah.
Makes sense that it should be a risk category 1 unless there is maybe like a BESS or something coupled with PV. At that point, you could consider the BESS part maybe category 2,
but you actually think it shouldn't be a category 1. You think it should be something less, right?
I think, generally speaking, I think tracker piles could be less. BESS, it doesn't really... It's a different...
The only thing that would affect BESS is seismic, right? Because they're so heavy.
Yeah.
But, then again, maybe we could reconsider it, right? There's a lot of arguments for it. But we're talking, I mean, those piles are much smaller on scale versus these PV piles.
Yeah,
if we're looking at a BESS site, there's like
80
20 per container, it's... it's scale is what it comes down to.
Right.
These PV sites, it's what we talked about earlier. It's thousands and thousands. And you brought this up by a tornado. Let's say a tornado hits a site. Unless the tornado, and these sites are sprawling and they're expansive. Unless the tornado weaves its way through.
It goes on every tractor, typewriter.
Yeah. This project that I had that got hit pretty hard. It got bad. It was bad.
Yeah.
But I didn't hear anything about piles being an issue, but modules.
Of course.
We need to find what can we replace these modules with that we can get right now.
Yeah. If you looked at those piles are probably fine.
Yeah.
Maybe the bolt holes got ripped, but that's repairable.
Yeah.
And that's what's going to happen. Those modules are just going to act like little umbrellas, and they're just going to fly away, Wizard of Oz style, and like the piles, they're
Wizard
gonna be in the
of
ground
Oz style.
Wow.
Yes.
So it is kind of just a little sad to see them, changing this to a risk category 2, because it's just a waste of resources. There's no reason to have that much steel in the ground.
Yeah, and for people doing renewable energy, it's like, I think we're also like, that's part of our things, like, well, stewards of the environment, we should probably be conscious of that, and using excess steel is like not in agreement with that. But
we're just talking about that. I got one question.
Here we go.
So, after the life cycle of a project, right? We've talked about what we do with the recycling of the modules or the inverters. What is the plan for the piles? Can they be reused somewhere else? Do you get recycled and melted down?
Yeah.
They'll recycle them. Yeah.
Just pull them out of the ground and put them back in the foundry and roll out new piles.
Nice. Yeah.
That's pretty.
Is that an industry that's already happening, or is that something that's like we see like 20 years when these projects come to life?
Steel recycling in general.
Yeah.
Right, but I just mean like this specific, because we're talking about like hundreds of thousands per site. Or
I don't think solar's old enough for that.
That's what I'm saying. Yeah. So eventually there's going to be this new.
We should go be pile pullers in 25 years.
Steel recyclers.
It's a good industry.
Yeah.
I mean,
well, module recycling is only in its infancy, and it is booming. Like that is a huge need, because just like the project that got hit by the tornado, it's like, well, there's going to be glass everywhere, and you can't just like throw it in the landfill.
Right. Yeah.
So, so we kind of touched on the present, what's happening in the industry. What are you looking for in the future? Where do you see our structural work in solar PV going beyond 2024?
I mean, right now we're growing as a company. So, let's just be real. This role is new to me this year, and we've kind of just been dealing with some, maybe, just getting settled in, getting this figured out. And we're kind of at that phase now where we're starting to look internally and discuss, like, what's the future? What can we do? We're doing a lot of things already that I think that are just kind of easy to overlook, because we're so used to just improving our tools, improving processes, becoming more efficient. I know you've had like a ton of, involvement in getting our pile plan group set up, like
that whole thing.
Yeah. And like really just improving on the product that we produce. Like, we already do awesome work and produce really high quality stuff, but like the beauty of this team is that everybody wants to be better. Everybody wants to do better.
They're addicted to continuous improvement.
It's crazy.
What is this?
Andy would love to hear that.
What is the size of your group right now?
11 people total.
Okay.
Including myself. Yeah. So it's small, but I mean, we're growing. There's the need for it. So we'll be adding people, hopefully.
How about a new grad who's listening to the podcast right now?
Love that.
That'd be great.
Yes.
We need that.
Yeah. But, so as we grow, I think there's going to be a lot of opportunities for us to start looking like, what else can we do? We've got our substation team here, and that's growing, and we're adding, we just added a SCADA guy. And so I'm thinking, maybe internally we start looking at, maybe getting our hands in helping substation, because they've got 2 structural guys. And
I was going to ask that.
It's a lot of work.
If you're involved in any of the structural for the substation.
Yeah.
Not really. We do help them out when they're, got a lot going on. But, I think maybe we'll start getting a little bit more involved with them and start looking more into what else can we do with renewable energy? What other markets are there that we can support in solar?
Yeah. And then, and you were just alluding to that, like industry-wide. Where do you see solar PV pile design going? Our bread and butter. Like, what needs to be done in the future, or opportunities, et cetera?
I mean, I think it's just us staying current with the new technology that these racking manufacturers are putting out, right? We're seeing a lot of people start using more ground screws, things like that. It's just, I think, staying on top of that, staying aware, and seeing what we can do to support that.
Yeah, I was going to the ground screws is a great point. I was going to ask maybe the silly question. Is there any other material that potentially could be used for these piles rather than steel? I know steel's probably the cheapest to use, but is there anything that you think could be a viable option?
There's stuff out there. We do hot rolled steel, right? A lot of people are starting to kind of push cold form You know, I spoke with a guy at RE Plus about, he has been working on this system of new shapes where they come in as a sheet and then they just roll them right there into the size you need. You know, and it's cool. It's interesting. So there's a lot of these new products coming out, and you know, we're always happy to get our hands in and start looking at it and see like, hey, is this going to work? You know, is this more cost effective for our clients? Is it going to be easier to install or procure? Because that's the big thing, are these procurement times on hot rolled steel. It takes months.
Yeah,
Is
to roll 60,000 piles. Yeah.
Is hot rolled steel more expensive than cold roll? Maybe you can explain the. I don't really know what that means. I mean, I mean, obviously one hot, one's cold. I get it, but like, what's the advantage of one over the other, I guess?
Yeah, I mean, hot rolled steel is going to be a higher strength steel because it's basically coming out of the forge hot. They're rolling it into the shape or protruding it into the shape that you need. Versus cold form, you know, it's already created as this cold steel, and then they roll it into shape, right? I'm not a metallurgical, you know, and I don't know. I'm not into like metal sciences.
It's a metallurgical gal. Metallurgical. Metallurgical, but you're not a metallurgical gal.
I see. That's a good one. Wow.
Now the show's over.
I know one of the other things we wanted to ask you about was kind of like, what are your influences, you know, to go in the direction you've gone?
Yeah, like from childhood or like...
Whatever you want to talk about.
I mean...
Yeah, who influences you? What's your influence?
I don't know, man.
Billie Eilish.
Yeah. Taylor Swift.
Taylor.
No, I'm not.
Are you a Swiftie?
I'm not.
No, me neither.
Yeah, me neither.
She dissed Celine Dion, so I've got some beef with her.
Really?
Oh, man.
Celine Dion just came back from her illness and sang at the Olympics.
Yeah, Celine Dion, she's a gem. We could talk a podcast just about Celine Dion, but I don't know who would listen to it.
We got to change batteries on the cameras.
Yeah, no, you know, I took a welding class in high school.
Sick.
Oh, wow.
Yeah, I don't know why.
MIG,
I did.
TIG,
yeah, all of it. And
Sick.
you know what? I was horrible at all of it, but it was fun to learn.
It's okay.
Yeah.
You can grind them down.
Yeah, exactly. I did a lot of grinding in that class. And it had some drafting coursework involved in that, and I was like, man, I really like this. And, you know, I was always intrigued by architecture and buildings, just things of beauty in that regard. And then I decided, I'd go into engineering, and civil engineering seemed great because I had a cousin who had just graduated with his master's, I think, in architecture, and he's like, don't do this, it's too much school, and you're just going to end up designing stairs and schools and stuff like that, you know. I mean, like, yeah, that's not as...
I did some stairs and I didn't like it.
I did stairs too. I'm not a fan of stairs.
Yeah.
So I ended up going into civil engineering, and then at some point I thought, you know, water resources, you know, and doing things like that. Everybody needs water. Everybody, you know, like it's critical for life. And I thought that was cool. Turned out I ended up liking steel and concrete design way more, you know, so it just kind of came from there. Yeah, I always wanted to do design work because it's fun. It's so much fun getting those numbers to work out right. You know, it's a beautiful product at the end of the day, but that's kind of just how I ended up here. I don't know.
So to close the show out, we want to ask one question. Anytime we're interviewing someone, if you had to give a piece of advice to someone, either a new grad or someone just coming into solar, let's say, this new industry, what would it be?
Man, that's a good question. You know, I think just find a company and a job that brings you joy, right? Make sure that you're able to find that joy in your life doing solar, you know, because that's just going to give you so much more fulfillment, so much more motivation. And that's, you know, when we have people in the right roles that have that joy every day, it builds that big picture where we're all producing like these grand projects together. So, you know, it's hard. Some days are hard, you know, and you have to go through those ups and downs, but you know, find the right spot for you that fits in with your culture and how you are as a person.
It's the things money can't buy, relationships.
Call it the solar coaster.
Yeah, on the solar coaster. Yes, of course.
Yeah, I mean,
In there.
would we have lasted this long in solar, you know, if we didn't genuinely enjoy the people we worked with and the company we were at?
Exactly.
You know, it's hard. It's a lot of work. So, you know, having that support group is so important.
Yeah, for sure.
You spend so much of your life at work, so you know, it has to be meaningful.
Yeah.
Think about you guys as my coworkers. You're my friends.
Yeah. Isn't that nice?
My friends.
That's the
warm fuzzy moment.
And on that note, thanks for listening and watching another great Sums of Solar podcast. Me, Russie, Pookie,
Freddy.
AB.
There it is. Like, share, subscribe, do that thing that you're supposed to do, especially the industry folks out there. If you know other folks in solar, you want them to hear about the sounds of solar, send it their way. Leave us a review also. We'll see you next time on the Sounds of Solar.